everyone, I'm here at the Chung Conference Center here in Liliendahl, and I'm here to see they have a science fair and some racing cars on exhibit. So I'm here. So let's see what we see, everyone.
National Science Fair competition and exhibition. Expand your mind to see all that's possible through science. We hope you enjoy the exhibition. Welcome to the Ministry of Culture, Youth and Sports National Science Fair competition and exhibition. Expand your mind to see all that's possible through science. We hope you enjoy the exhibition.
I'm still at the Autotune Center, but before the place gets dark, I'm just gonna walk around a bit and show you guys. I'm gonna show you all what a beautiful structure this is. It's a really nice piece of architecture. So this is part of the exterior of the Autotune Center here in Liliendahl. I'll be going inside.
As they walk in. Hold on a sec, hold on a sec.
Why did you take
Get a hold of it. Move it back in, all right?
friendly incinerator? This is something that is lighted. This is something. Hi, good afternoon. So I have a YouTube channel and yes, I'm here. Secondary. This is an eco brick. Yes. So does someone care to explain what exactly it's made of? Hi everyone. I'm Ashalton. Is that right? Ashalton.
Yeah.
Ashalton Homework Club building with eco bricks. Okay, and one of the students here is gonna give me some information as to how they produce this eco-friendly brick. Okay, you can go right ahead.
So we're using plastic waste,
Plastic waste, okay.
eco brick, right? So it takes a lot of plastic once in a while.
Some water.
No, it takes a lot of plastic.
Plastic, okay.
So recycling plastic to make
Okay.
the eco brick and we create a wall.
Sorry?
A wall. It's a wall. It's a wall. You can move around some pictures, examples of people using brick. Wall.
Okay, so what's the process? How does it move from this stage to that stage? What happens really?
We line them out and we put the mixture of cement around.
Okay, so this is inside of this right now. Is that it? What you're saying?
Yes.
Okay, so this here, the bottom of the plastic is inside of this here, and then you cement over it.
Yeah, plastic.
Okay, so is this hollow, or it has some sort of hollowness inside, or is it solid with that?
It's solid.
It's solid, so the concrete goes between.
Yeah.
Okay, all right. And how long does it take to dry? Same regular timings like your regular. All right. Okay, that's good. Great, thanks. Mommy. Hi.
Hi, good afternoon.
Good afternoon. Which school you guys from?
Huh?
You guys from a particular school?
No, we're just an individual group.
Individual group? Okay, so explain to me, I'm interested in this very much.
So we're Ultimatus Electricus.
Okay.
So our project is based on again having long blackouts and us not wanting blackouts. So currently with GPL is that we gotta report a problem, either call them or WhatsApp them before they're able to come and sort out the problem.
Okay.
So we built a device, it's called a wireless line fault indicator.
Okay.
So
Great.
what it does is that it checks for faults in transmission lines.
Great.
And it sends a wireless message to the servicemen around or the person working in the area. So it sends a wireless message to them. So now they'll be able to know exactly where the problem is.
So, all right. So my brain is a bit tired right now, but let's say from point A to point B, all right? Certain amount of electricity flow from point A to point B. I want to know, how do you detect, what method do you use to detect that?
Right. So you see this clip? It's
Okay.
a current. It measures the current.
Okay.
So if
That
there's
has
a
to be on the line.
So right now you see bulbs are off. So
Yeah.
you see here, it's red,
Okay,
right?
so you have a computer simulation?
Yeah.
No, it's not simulation.
it's a live.
Live.
It's
It's
live.
live data. So you see those are off
No,
right now.
but that's, I mean, you have an app online to show you. Okay.
So should I put it? Should I put it
If
on?
I were to put it on,
Okay.
The data is gonna get updated,
Okay.
and
It shows you the active nodes and whatever.
yeah. Go into monitoring. You know, should go into monitor. Go into monitoring. So it shows you the nodes, the GPS.
Okay, great. This is great. And the location and the line and
Yeah.
so what you would have done, you would have had to have a good geography of all the transmission line that
Yeah,
is
so
currently operational for
The
GPL.
idea is, so when they install the device,
Yes,
they will make it with the GPS coordinates,
that's right.
right? So you can see there, it's plotting the current here live.
Yes.
So should there be any changes in the current and so on, you know, the current is just going to drop off, and it's going to give them a warning, and also, and then there's a change in the network, I get notified by SMS.
Okay, great. I like this. This is so tell me something. So this only picks up for when there's a drop, when there's a breakage or anything. What about if there's a fire on the pole? In that sense.
Well, fires and poles, you'd have to get there's different type of sensitivity, but if the fire should cause any disruption in the network, it's going to detect it.
It's gonna depend. Okay. I think I recall in some countries they use drones. Do you guys use any sort of that kind of technology? Because the drones, they have sensors that can detect breakage as well, and they can probably help in terms of be that component in it, you know, a backup in terms of, because this is just one way you guys have here, meaning one form, right? There's always a backup when it comes when in service provider. What other backup?
Well, this here, first of all, we designed in such a way that, first of all, it doesn't require any existing infrastructure. So it doesn't require GT&T, it doesn't require DDCell, it doesn't require internet. It uses its own local network.
Okay.
So the idea is that, and it's also utilize some mesh network technology.
Okay.
So there's no single point of failure.
Okay.
Should one go down, the rest is
Okay.
going to remain operational. So
Okay.
the backup is that, you know, we have protocols in place to reroute data, transfer to other nodes. Remember now, the data is we transfer from one node to the other node to the other node to the other. So, should there be a point of failure, the data
they
just
would
go
reroute the
just go
data.
All right. So who is the? Do you have your own? Like, are you using GT&T system? Are you using Starlink satellite?
No.
Elon Musk? What are you
Using
using?
LoRa.
LAN? Local area network.
No, LoRa.
Long range
Long
communication.
range, huh?
So the military usually uses it a lot. I don't think Guyana military, but a lot of overseas military uses it because line of sight
I
transmission
know about line of sight
is
transmission, yes.
50 kilometers.
Okay.
And in urban areas and so on, it's about 3 to 5 kilometers radius.
Yeah.
Yes, but you know everything. My thing is that everything, anything could be interrupted by signals once you have the technology available, even if it's line of sight or whatever it is. So how do you cater for that?
Well, since you seem to be more technical with this. So we're currently running AES 128 encryption, and we're using a 32-bit encryption key.
Okay.
And we're also using things like pocket counters and so on to
Oh, so see, there's a drop-in packet.
there's a drop-in packets. And also
Okay.
we're implementing this something called the IEEE
I know
802.11
about that.
MACA protocol, multiple access collection of violence for wireless networks. So those now ensure that we don't lose any packet in the transmission.
That's right.
And should there be a packet drop, it's gonna retransmit the packet until
Okay, and then you can locate where exactly you're losing the packets or where it's hold up. Or
should
whatever.
we decide to locate it.
All right. All right. Great. I like it.
Decorate.
That's okay.
Yes. Hi everyone. I'm at the University of Guyana Robotics Club. So let's see what these fellows have here.
So this is the first ever locally made semi-industrial robotic arm by University of Guyana Robotics Club. So basically what it is, it operates on the Arduino microchip, which is like a small computer
Yes.
that sends signals to the various servos that help to coordinate different movements. So
Okay.
essentially what I do is that I program on the Arduino IDE, which uses C++ programming,
Okay.
and then it takes relatively 3 seconds, like right now I'm uploading one, to send to the computer, which then sends to this.
Okay.
And the reason for the delay is because this model is the smallest one, Arduino Uno, but it has a larger model called the Arduino Mega that takes less than 1 second actually to upload. So the current model is just for educational purposes, like a teaching aid you could say, so that children could get into robotics maybe from like a smaller age to help boost their critical thinking and whatnot. As you can see here, it has various examples of robotic arms, and those like cost usually $70,000 to $270,000. But make a wild guess how much you would think this would cost. Like from the printed parts. These are 3D printed parts actually. And the
Okay.
servos and so.
All right, so okay, everyone, these are 3D printed parts, and this everything is controlled from the
Right.
software here. And this here, everyone, is like a mini computer for those who have used Raspberry Pi and so on. These are some of these are small motherboards, basically like your computer system that you can connect your stuff, the interface. So this is the hardware, and the software is done on your computer system. So with the tree thing and on all the interfacing, you get a working robotic arm. So this is pretty much a model that is used in the industrial warehouses and places. So this is just a model he has constructed, a University of Guyana team here. So this is a model. So do you want to show how this arm really moves?
Oh, so I input the code now, which will then turn this here and open the claw. So here.
Okay, so it can open.
And there are several axes of movement. So this one controls the opening of the claw.
Okay.
This one raises up or lowers the claw, and this one turns the claw completely.
Okay, great.
And then it have other ones, these bigger ones actually move in a circular motion, like a full circle.
Okay.
So it's like your elbow and your shoulder. That's how
Alright.
like how these move. That's how these operate.
Okay, great. So this is a product. This piece on display here is a product of the University of Guyana
Robotics Club.
Yeah, this is awesome. Awesome, guys. Shout out to the University of Guyana lecturers. Yes, I'm a product of the University of Guyana Department of Computer Sciences. A little bit thing with my robotics aspect, but not the audio part. So, great job, guys. Enjoy.
Thank you.
Right? This is really encouraging. Have a good evening.